is that Tim and I have been assigned the task of setting the stage for the discussions over the next couple of days by reminding us of who we are and where we came from and what we have in common. And I am unpleasantly aware that this is the sort of honor that's traditionally reserved as an act of pity or kindness for those members of an intellectual community who are now too old and too tired and too feeble-minded to contribute in any more serious or original way to the actual business at hand. Okay, so be it. I will do as I've been commanded, as well and as graciously as I can. So here's the deal. 100 years ago, or maybe a little more, physics aspired to produce a complete and unified and seamless and philosophically realistic account of the entirety of nature. It aspired, that is, to tell us straightforwardly what the world is. And aspirations like that suddenly came to look, I don't know, quaint or childish, or hopeless or out of date under the spectacular assault of quantum mechanics. Bohr and his circle quickly became convinced that the so-called problem of measurement was no ordinary scientific problem, that as a matter of fact it was like nothing we had ever run into before, that what we were up against here for the first time were the ultimate limits of the scientific project itself. The business of representing the world in scientific terms now seemed to depend on one's first establishing some sort of a boundary between observed and observer, or between mind and body, or between subject and object, or between what could be spoken of in classical language and what could not. Moreover, Bohr and his circle were convinced that this boundary itself, even though it was something on which our most fundamental scientific ideas crucially depended, was not the sort of thing on which scientific investigation could ever shed any light, that there was something permanently mysterious about it, or something arbitrary, or something subjective, or something merely verbal. A host of what had previously seemed like perfectly sensible questions about the physical situation of the world were declared somehow unaskable, or even worse, unintelligible. There was talk, and I'm quoting Bohr here, of the renunciation in each experimental arrangement of one or the other of the aspects of the description of physical phenomena. There was talk, and I quote him again, of the necessity of some, quote, radical revision of our attitude toward physical reality. And all of this, as all of you know, fell upon the physics of that other time with the terrible force of a divine pronouncement. And the business of inquiring any further into such matters was relentlessly denounced and misrepresented and hunted down and rooted out and quite severely punished. And part of what I take it all of us have in common here is the thought that this amounted to a nightmare. And part of what I take it we're trying to do here is to wake up. And part of what I take it we're seeking after here, part of what I take it we're alluding to when we say we want a quantum theory without observers, is a quantum theory that tells us in an honest, intelligible, straightforward, flat-footed, old-fashioned, regular guy kind of a way what the world is. Now, it should go without saying that any universal, empirically adequate, fundamental scientific theory of the world is going to need to accommodate the existence of such things as observers, for the simple reason that such things as observers actually empirically exist. The business of referring to what we want as a quantum theory without observers has to do rather with the contingent historical fact that a lot of the general philosophical shenanigans of the Copenhagen interpretation, a lot, that is, of what was dogmatic and unintelligible and high-toned and newfangled and downright dishonest about the Copenhagen interpretation, tended to revolve, as I mentioned above, around some deep and essential and mysterious and fundamental and not further analyzable and scientifically disreputable distinction between the object of observation and its subject. And one of the things we want, I take it, is a version of quantum mechanics in which no such distinctions as that play any role. One of the things we want, I take it, is a version of quantum mechanics that treats observers in much the same way as they're treated in classical physics. A version of quantum mechanics, that is, that treats observers for all purposes and under all circumstances, at least at the level of principle, as nothing more or less than particular states or arrangements or configurations of garden variety fundamental physical degrees of freedom. But I take it most of us want a good deal more than just that. I take it that most of us here are going to agree that it ought to be possible to write down the complete microscopic physical theory of the universe without, for example, to remember Bell here, using words like measurement. And I take it that most of us here will agree that the fundamental postulates of a theory like that ought not include claims about what is or isn't observable. And I take it that most of us here will agree that the business of understanding the picture of the world that a theory like that presents to us ought not require any changes in the laws of logic or in the axioms of probability or in our ordinary conceptions of what it is to be real or of what it is to exist. What we want, once again, is a version of quantum theory that offers us a picture of the world that's at least as concrete and understandable and straightforward and as free of subtlety and mystery and general philosophical shenanigans as the one we get from classical mechanics. And it has always been central to the business of making progress with the foundations of quantum mechanics that we ask ourselves over and over at every new twist and turn of our investigations, in every new language we invent, at every new level of understanding that we achieve exactly what that means. And I take it that a part of my job here is to provoke yet another conversation about that. A conversation appropriate to the particular problems we're facing and to the particular languages that we're speaking and to the particular understanding we have achieved as of this particular historical moment. And I take it that the most straightforward and most useful and most efficient way of provoking a conversation like that is just to put something on the table that people can react to, that's going to provoke an attack, that's going to provoke a critique, that's going to provoke a conversation. Good. So here's what I'll put on the table. The way it feels to me, or the way it feels to me for the purposes of provoking this conversation, that is, the way I think it feels to me, or the way it often feels to me, or something like that, is that the proper business of a fundamental physical theory is to tell us what there is and what it does, and that any such theory that proposes to tell us anything more or anything else is flirting with philosophical shenanigans. Fundamental physical theories ought not be in the business, for example, of making fundamental posits about what is and is not observable. The facts about what is and is not observable ought rather to be derivable in principle as theorems from the more fundamental facts about what there is and what it does. And I'm thinking here of beautiful work by a bunch of people in this room about, say, the emergence of Hermitian operators as a significant mathematical object in theories like Bohmian mechanics and stuff like that. And fundamental physical theories ought not be in the business of stipulating bridge laws or rules of correspondence between the language of what there fundamentally is and what it does, and the language of tables and chairs and buildings and pointers and the rest of the contents of our everyday experience of the world. People sometimes talk, for example, as if there's something along the lines of a fundamental stipulation of statistical mechanics over and above the stipulations about what there fundamentally is and what it does, to the effect that what we call, say, the temperature of a gas, when we're describing it in thermodynamic language, is associated with the mean kinetic energy of its fundamental particulate constituents. And that just seems radically and entirely and preposterously wrong to me. What we're doing, it seems to me, when we say that the temperature of a gas is the mean kinetic energy of its fundamental particulate constituents, is a matter of noticing and pointing out that the unique fundamental microscopic feature of a gas that satisfies all of the ordinary functional criteria of being a temperature, that the unique fundamental microscopic feature of a gas that's sitting precisely at what you might call the temperature node of the network of causal relations that connects temperatures and pressures and volumes and thermometers and steam engines and refrigerators and geothermal cavities and human sensory organs with one another, is the mean kinetic energy of the gas's fundamental particulate constituents. And this is not something that the fundamental physical theory stipulates over and above what it stipulates about what there is and what it does. This, rather, is something that we can in principle see, something that we can in principle show, that we can in principle derive as a theorem from nothing whatever over and above the fundamental facts about what there is and what it does. And I'm puzzled in very much the same spirit and by very much the same token about how there could be room in a properly formulated fundamental physical theory of the world for distinctions, say, between primary and secondary degrees of fundamental being, or for considerations of what it is that the theory in question is actually about, or for talk of the role or the purpose or the function of this or that piece of what the theory in question says there fundamentally is. The way it feels to me, or the way I think it feels to me, or the way it often feels to me, or the way I'll pretend it feels to me for provoking a conversation here, is that a properly formulated fundamental physical theory of the world ought to treat fundamental physical existence as an absolutely simple and primitive and univocal idea, and that a properly formulated fundamental physical theory of the world ought to be about nothing more or less or other than the entirety of what fundamentally physically exists, and that a properly formulated fundamental physical theory of the world ought to reject talk about the role or the purpose or the function of this or that piece of what there fundamentally physically is as confused metaphorical nonsense. And insofar as I'm aware, and I guess this is what amounts to the punchline of this little opening sermon here, there's no way of satisfying the sorts of demands I've just spelled out in the context of quantum theory, other than to think of the quantum mechanical wave function itself as a full-fledged, freestanding, concrete, fundamental physical object. And I want to take a few minutes to remind you of what a thought like that, what a demand like that, brings with it. The most striking, let me actually open up the, good. I'll need to refer to this in a minute. The most striking and controversial and difficult feature of this approach is, of course, that the stage on which such objects, that is, objects such as wave functions, must make their appearance, the stage, that is, on which any such understanding of quantum mechanics is going to have to depict the history of the world as playing itself out, is a mind-numbingly high-dimensional space, a space more particularly with the same geometrical structure as what gets referred to in more conventional understandings of quantum mechanics as the configuration space of the world, a space whose dimensionality in the non-relativistic case, in the first quantized case, is 3 times as large as the total number of elementary particles in the universe. And it's obviously going to be incumbent on any such understanding to explain our very vivid and very deep-seated impression to the contrary. And I'll talk about that in a minute. Let me just first make it clear what the basic metaphysics of such a picture is. The sorts of physical objects that wave functions are, on this way of thinking, are plainly fields. which is to say, they're the sorts of objects whose states one specifies by specifying the values of some set of numbers at every point in the arena where they live. The sorts of objects whose states one specifies, in this case, by specifying the values of two numbers, one of which is usually referred to as an amplitude and the other as a phase, at every point in the configuration space of the universe, or in this space isomorphic to the configuration space of the universe.